Good morning, everyone. I'm pleased to present our study titled Computational Evaluation Scientific Textual Quality Synergies between CohLitheSP and Large Language Models. Our research explores a new frontier in academic auditing and misinformation detection, specifically designed to address the challenges of the digital era in social sciences and humanities. We aim to show how combining traditional algorithmic tools with the qualitative reasoning of AI can safeguard scientific rigor. As higher education undergoes a rapid technological shift, we must rethink how we evaluate academic literature. Historically, we have relied on surface level metrics like the flash Kincaid of Lexile scores. While these are robust predictors of cognitive reading time, they are fundamentally limited. They only measure the length of words and sentences. They are entirely blind to global cohesion, discourse, meaning, and most importantly, the actual truth of a text. Advanced linguistics has moved towards multi-level frameworks that track lexical sophistication, syntactic complexity, and global cohesion. A vital concept here is the compensatory phenomenon. In scientific writing, authors often simplify their sentence structures to balance out highly abstract or technical vocabularies. While LLMs are a game changer for these analyses, using them effectively requires developing specialized professional AI competence to avoid structural bias or hallucinations. The core objective of this study is to evaluate scientific text quality by integrating the CohLitheSP algorithm with the semantic inference of large language models. Operationally, we set out to measure the reliability of AI-based expert roles, derive mathematical weights for Spanish text metrics using the method of least squares, and validate the system's ability to distinguish authentic scientific discourse from sophisticated fake texts. We tested our model using a corpus of 14 documents regarding the historical search for Menkaura's mummy, which provided a dense mix of archaeology and international law. This corpus was split between authentic records and fake pseudoscientific texts generated by AI. We used the CohLitheSP framework to extract five key Spanish adaptive metrics: narrativity, readability, ease, referential cohesion, deep cohesion, and lexical concreteness. Next, we implemented a multi-agent panel. We prompted an LLM to adopt five distinct expert personas, people, including an archaeologist, a psychologist, and a data scientist, to independently audit the text. To determine a final score, we used a modified formula to calculate subjective rigor, which balances the presence of objective valid knowledge against the degree of sensationalism. The results were revealing. The AI agent showed high precision with less than 6% deviation when auditing technical structural mechanics. However, when we applied the method of least squares, we found that high scientific rigor is actually associated with negative weights for cohesion and concreteness. This mathematically proves that rigorous scientific prose is often characterized by dense, abstract, and unsimplified structure that reject local redundancy. This brings us to our most critical finding, the structural usability paradox. Our data shows that fake AI-generated text routinely exhibit higher readability and lower complexity than authentic literature. Essentially, generative AI naturally over-optimizes text mechanics, creating highly fluid and accessible prose that is factually vacant or historically inaccurate. This disconnect between structural and truth is a major challenge for academic auditing. Under traditional schemes, usability is a positive marker of accessibility. However, in a scientific context, extreme usability can actually be a red flag for linguistic manipulation. This is why triangulation is essential. CohLitheSP provides objective mechanical baselines, while LLM expert agents evaluate the underlying semantic consistency and truth. In conclusion, our hybrid model represents a cutting-edge paradigm for quality assurance. We recommend two main paths forward. First, contextual calibration to ensure different disciplines aren't unfairly penalized for the inherent complexity. And second, the development of critical AI competence to train evaluators to see through surface level over optimization and recognize genuine intellectual rigor. Thank you.